Many of you are familiar with NASA's planet hunting mission, NASA Kepler. And today we have Dr. Barclay joining us, and he has been with the mission for a number of years now, making some pretty amazing discoveries. I won't steal his thunder, so I'll let you take it away. And if I've got some things up.
Sure. So yeah, I'm a research scientist working within NASA's Kepler mission. For those, hopefully everyone's familiar with Kepler, but basically we're trying to find planets around other stars. Really, our fundamental question involves probing at, like, are we alone in the universe? And to start trying to do that, we're trying to see, are there places like our own planet elsewhere in the universe? So recently you may have heard the spacecraft's not doing so well, has some issues, but actually for us working on the data, this isn't the huge problem it seems. We've got so much data that has revolutionized our understanding, and it's continuing to, and it's going to have enough data for another generation to try and delve through. So it's really great news. So what we've been doing to find these planets, we look for a planet going around another star. As it crosses the face of that star, we see a dip in brightness. We look at 150,000 stars continuously, and we look for these dips. How often the dips happen tell us how big the planet is, and tell us the period of the planet, how long it takes to go around. That tells us something about the temperature. How deep the dips are tells us how big the planet is. So we get temperature, roughly, and we get a size of the planet. Well, we know how big we are. We're big enough to be rocky, but not so we're small enough to be rocky. If you go too big, you become a gas giant. If you go too small, you can't hold an atmosphere. So that's kind of one bound of what might be a habitable place. We're also a nice temperature where liquid water can exist. That's our other guess at what a habitable place might be. We're not very inventive, I guess. We have no idea really what might be habitable or what life is like elsewhere. But we guess it's probably like us because, I don't know, maybe egocentric. Yeah, with a sample of one, we extrapolate to the universe. This is beautiful. Yeah, so we've made some really fun discoveries. One of the I was led recently is linked nicely to this sort of lunar-themed day. We're looking for what are the smallest things we can find. This is like really pushing the limits. We've built the best sort of most sensitive instrument ever to sort of do this work. Yet we always want to do better. So we're really pushing the limits of how small we can go, and this is how small we think we can go. This is going to be tough to beat. These are the size of some of the planets in a system called Kepler 37. You see there are two larger planets here, and here's Earth, Earth being one of the large planets. The smallest planet in the system here, Kepler 37b, is the same size as our own moon. This is smaller than any planet inside our own in the solar system. So the mission's not just showing that we can find things like our own solar system, we can find things smaller than we find in our own solar system. We find there's a huge array of everything out there. Planets are everywhere, and they're all shapes and sizes, which I think is really exciting. The thing I like about this most is that we have a planet found that was smaller than the Earth, and no one cared, because Earth-sized things are kind of dull and boring now. It's old news. And I just want to finish by saying that small, while it's interesting, the most interesting thing is finding temperate worlds, small temperate worlds like our own. And that's where we're at the minute. The sort of hot off the press stuff that we're working on is Earth-sized planets with a temperature like Earth, but orbiting stars cooler than the sun. This is going to be coming out soon. This is the latest results as of this week. We think we have 2 to 3 Earth-like planets around stars cooler than our own sun. So I guess I'll leave it there. This came out earlier this year. These were the record holders. These are planets that are about 40 to 60% bigger than our own. That's possibly rocky, but more likely some kind of crazy water world, like Kevin Costner might live on.
Do you know if any of them have an active magnetosphere, or?
The one limitation in a mission like Kepler and some of these other small missions is we don't have beautiful pictures like Hubble. So we create these wonderful artistic renditions, but honestly they're not far off being an absolute random guess. There is some science that goes into that, but it's very difficult to know what they look like. So knowing anything like the magnetosphere is even harder. We don't know anything about the atmospheres of these yet. So when we think of science missions in the future to understand other planets, it's all going to be about atmospheres.
Which is a perfect segue. Thank you so much, Tom, for your time.
By cool